Hello dear students, welcome to mathematics class. So in the last class we have discussed the definition of linear differential equation with constant coefficients, and also we have discussed that synthetic division and one example on the linear differential equation with constant coefficients. So in this class we are discuss some more examples on that linear differential equations with constant coefficients. So here this is the example. Solve the differential equation d cube y by dx cube minus 7 into dy by dx minus 6y is equal to 0. So first we need to write the equation in the symbolic form, because that is the first step to solve the linear differential equation with the constant coefficients. So here we are using the operator capital D for the d by dx, then we will get the symbolic form of the differential equation. So here this is equal to d cube y, because here it is d cube y by dx cube, then d cube y minus 7, that is constant as it is, then dy by dx is there, that can be written as dy minus 6y is equal to 0. Then in the next step we are writing that y in common. So therefore that is d cube minus 7d minus 6 into y is equal to 0. So therefore here this is the symbolic form of the given differential equation. And now this is the symbolic coefficient of y. By equating this symbolic coefficient to 0, we will get the auxiliary equation. So while writing the auxiliary equation, we are putting d is equal to small m. So therefore the auxiliary equation is m cube minus 7m minus 6 equal to 0. Since here order of the equation is 3, then it has 3 roots. The first root can be obtained by using the trial and error method. So by substituting m equal to 0, plus or minus 1, plus or minus 2, and so on, for which value the equation will satisfy, that is the first root of the equation. So here by substituting m equal to minus 1, we can satisfy the equation, that is minus 1 whole cube minus 1, then here minus 7 into minus 1, that becomes plus 7, and minus 6. So minus 1 minus 6 minus 7 and plus 7 is equal to 0. So 0 equal to 0, that is the equation satisfied for the given root m equal to minus 1. So therefore then we got the first root, then use the synthetic division to reduce the order of the equation. So here coefficients of this equation, the first coefficient is plus 1, and next lower order is 2, but here there is no m square, means its coefficient is equal to 0, then minus 7 minus 6, and the first root is minus 1. So we need to take the first value as it is, then 1 into minus 1, adding these two we will get minus 1, then minus 1 into minus 1, that is plus 1, then minus 7 plus 1 minus 6, minus 6 into minus 1 plus 6, which is equal to 0. So therefore order of the differential equation will become m square minus m minus 6 equal to 0. Now that cubic equation becomes quadratic, and by using the factorization we can easily factorize this equation and find the roots. Now m square minus 3m plus 2m minus 6 equal to 0, m is common, m minus 3 plus 2 is common, m minus 3. So therefore m minus 3 and m plus 2 are the two factors of this quadratic equation. Then it implies that m equal to 3 and m equal to minus 2 are the roots of this quadratic equation. So here we have total 3 roots, m equal to minus 1, m equal to 3, m equal to minus 2. Here you can use any one of them as the first root, second root and third root. There is no order for the roots. You can take m1, m2, m3 as your wish. So here I am considering m1 equal to minus 1, m2 equal to 3, m3 is equal to minus 2. So therefore the complete solution of this differential equation y is equal to, so here minus 1, 3 and minus 2, all the 3 roots are real because there is no imaginary part or square root of negative number. So therefore all of them are real and all of them are distinct. So yesterday we know, or in the previous class we have written the complementary function for the roots, or depending on the nature of the roots we have written the complementary function. Now 3 real and distinct roots. If 3 distinct roots are there, or here we have 2 real and distinct roots, for that c1 into e power m1x plus c2 e power m2x. So similarly if there are 3 distinct roots, then the complementary function will be c1 e power m1x, c2 e power m2x and c3 e power m3x. So therefore here y is equal to c1 e power m1x. What is m1? Minus 1, so minus x. c2 e power m2x, that is 3x, plus c3 e power minus 2x. So therefore here this is the complete solution of the differential equation d cube y minus 7 dy by dx minus 6y is equal to 0. So these are the 3 roots of the differential equation and this is the complementary function for that differential equation. The complementary function itself is the complete solution for this differential equation, since RHS of the differential equation is equal to 0. The next example is d cube y by dx cube minus 9 into d square y by dx square plus 23 dy by dx minus 15y is equal to 0. So here the symbolic form of this differential equation is d cube minus 9d square plus 23d minus 15y equal to 0. So now let us write the auxiliary equation for this differential equation. So auxiliary equation is m cube minus 9m square plus 23m minus 15 equal to 0. So here also the order of the auxiliary equation is 3. So it will have the 3 roots. The first root can be obtained by using the trial and error method. So here by using the trial and error method we can put m equal to 1. So m is equal to 1 is the first root of the equation. Now we can use the synthetic division for the next lower order equation. Now it is coefficient of d cube 1, coefficient of d square minus 9, coefficient of d 23 and the constant term is 15, right, and the first root is 1. Now take this one as it is. Now 1 into 1 is 1, then minus 9 plus 1 minus 8, minus 8 into 1 minus 8, 23 minus 8 is 15, then 15 into 1 is 15, the last term must be is equal to 0. So now the lower order equation, that is m square minus 8m plus 15 is equal to 0. So therefore now it is the quadratic equation. Then if it is possible to factorize, then factorize, otherwise you can use the formula, that is Sridhar's formula, that minus b plus or minus square root of b square minus 4ac divided by 2a, and this is m square minus 5m minus 3m plus 15 equal to 0. Here m into m minus 5 minus 3 into m minus 5 equal to 0. So, m minus 5, m minus 3 is equal to 0. So, m minus 5 and m minus 3 are the two factors, and m equal to 5 and 3. So, these two are the roots of the equation m square minus 8m plus 15 equal to 0. Now, the roots of this equation 1, 5, 3, all the three are real roots and they are the distinct roots. So, therefore, in the previous examples also we have the same 3 roots and 3 are distinct. So, whenever we have the distinct roots, then the complementary function is given by c1 e power m1x plus c2 e power m2x plus c3 e power m3x plus c4 e power m4x and so on. Depending on the number of roots, we can write the terms in the complementary function. So, the complete solution is y is equal to c1 e power x, because the first root is 1, so it is 1 into x, plus c2 e power 5x plus c3 e power 3x. So, this is the way to write the complementary function for the differential equation when RHS is 0. Whenever RHS is 0, the complementary function itself is the complete solution for the given differential equation. The next example is d cube minus 2d square plus 4d minus 8 into y is equal to 0. So, here the symbolic form of the differential equation is given directly. Then it is no need to write again the symbolic form, because already it is given the symbolic form. Just write the auxiliary equation and proceed. So, here the auxiliary equation of this differential equation is m cube minus 2 m square plus 4m minus 8 equal to 0. M cube minus 2m square plus 4m minus 8 equal to 0 is the auxiliary equation. Here also the root, or sorry, the order of the auxiliary equation is 3, hence this also has the 3 roots. So, here this can be written as, so in the first two terms we can take that m square common, right, m square common, then remaining term m minus 2 plus here 4 common, remaining m minus 2 is equal to 0. So, this can be solved by using synthetic division or by using factorization. Here factorization is possible, so therefore we are going to find the roots by using factorization. So, now m minus 2 is common for both the terms, then it is m minus 2, then remaining m square plus 4 equal to 0. So, m minus 2 equal to 0 and m square plus 4 equal to 0. So, these two are the factors. Then m equal to 2 is the first root. Now, m square equal to what? Minus 4. M square equal to, sorry, m square plus 4 equal to 0, then it implies m square equal to minus 4, then m is equal to plus or minus. Whenever we are taking the square root, that will be plus or minus square root of minus 4. So, we know the square root of 4, that is equal to 2. So, therefore, plus or minus 2 into square root of minus 1, which is equal to plus or minus 2i. So, therefore, here we have one real root and one complex root, right. So, therefore, m equal to 2, m equal to 0 plus or minus 2i, because there is no real part for the complex number plus or minus 2i. Now, look at the chart. So, here whenever complex roots are exist, then the complementary function will be e power alpha x, where alpha is real part of the complex number. Then C1 cos beta x plus C2 sin beta x, where beta is the imaginary part of the complex number. So, in this example we have one real root and one pair of complex roots, right. So, therefore, here the complete solution is y equal to, this is the first root. So, therefore, it is C1 e power 2x, that is the first root which is real, hence its complementary function is given by C1 e power 2x plus, next we will go for the second root which is a pair of a complex number 0 plus or minus 2y. So, it is e power 0x because e power alpha x is there. So, e power 0x, then we have already taken C1, then the next constant is C2 cos 2x because in place of beta we have 2. So, therefore, cos 2x plus, next is C3 sin 2x. So, this is the complementary function of the given differential equation. So, here it is C1 e power 2x plus, we know that e power 0 is 1. So, therefore, its value is 1, then simply it is C2 cos 2x plus C3 sin 2x. So, therefore, this is the solution for the given differential equation. The next example is d power 4 minus 5d square plus 4 into y is equal to 0. So, here the auxiliary equation is m power 4 minus 5m square plus 4 equal to 0. Since the order of this equation is 4, then we need to find the roots by trial and error method. So, first m equal to 1 is the first root. So, here for this the equation will satisfy, hence it is the first root. Now, by using the synthetic division, that is, now write the coefficients 1 which is the coefficient of m power 4, then m cube, here there is no m cube means its coefficient is 0, then m square minus 5 and there is no m, again its coefficient is 0, then the constant term is 4. And by considering the first root, the first root is 1. So, 1 as it is, 1 into 1 1, 0 plus 1 is 1, 1 into 1 is again 1, minus 5 plus 1 is minus 4. So, minus 4 into 1 is minus 4, 0 into minus 4 is, 0 plus minus 4 is minus 4, then minus 4 into 1, that is minus 4, 4 minus 4 is 0. So, now the order of the auxiliary equation will reduce to 3, that is m cube minus m square minus 4m minus 4 equal to 0. That is the next lower order equation because the given order is 4. Now, by using the synthetic division, we have reduced the order to 3. Then again by using the trial and error method, find its root. Now, m equal to 2, m equal to 2 is the second root of this equation. Then again using the synthetic division, the coefficients are 1, minus 1, minus 4, minus 4 and the root is 2. The first value we need to consider as it is, there 1 into 2 is 2, minus 1 plus 2 is 1, 1 into 2 is 2, minus 4 plus 2 is minus 2. So, here m cube plus m square because 1 minus 4 minus 4. So, m cube plus m square, then it is plus 1. So, 1 plus 2 is 3, then 3 into 2 is 6, then 6 minus 4 is plus 2. then 2 into 2 is 4, here it is equal to 0. So therefore, the order of the equation is m square minus 3 plus 3m plus 2 is equal to 0. M square plus 3m plus 2 is equal to 0. Now it is quadratic equation, so we can easily factorize this one, we will get the roots. Then m square plus 2m plus m plus 2 is equal to 0, m plus 2 plus 1 m plus 2 is equal to 0. Then m plus 2 and m plus 1, these are the two roots of the equation. So these two are the factors. Now the roots are m equal to minus 2 and m equal to minus 1. So therefore, here we have 4 roots of this auxiliary equation. They are m equal to, the first root is 1, second root is 2, third root is minus 2 and minus 1. So therefore, the complete solution of this equation y is equal to c1 e power x, first root is 1, plus c2 e power 2x plus c3 e power minus 2x, c4 e power minus x. So it is the complete solution of the given differential equation. So here the equation is d power 4 minus 5d square plus 4 into y equal to 0. Here it is the auxiliary equation, first root m equal to 1, second root m equal to 2, third root is m equal to minus 2 and fourth root is m equal to minus 1. Here order of the roots does not matter, the order of the root is independent. You can take the fourth root as the first root, second root as the third root as the first root, it is independent, right? So order of the roots does not matter. So while finding the roots only, we are considering the first root, second root, third root, fourth root, but while writing the solution for the given differential equation, you can use randomly as the first root, second root, third root and fourth root.